Okay. This is confusing because we have two different compounds that are similar, the S2O8 2 minus and the S2O3 2 minus. So we have the persulfate is the S2O8. Oh, and then we've got the tetrathionate and the thiosulfate. So those can be really confusing. What we're looking for is that primary reaction number 1. So we're trying to find the rate of reaction 1. So this reaction. And the way that we're going to do that is by setting up a clock reaction. So our clock reaction is number 2. The way that's going to help is that in the first reaction, when we form the iodine, the I2, because we've added the thiosulfate, it's going to react with that iodine right away. Basically, this one is very fast. And we're counting on that because as soon as we get any iodine forming, we're going to have a reaction with a starch. So what we want to do is enter a known concentration. So we add known S2O3. We know that concentration, and so we're going to use that to figure out how fast the reaction is going. So that's our known concentration right here. As soon as all of the thiosulfate is used up, then we see the color change. So until the S2O3 is gone, every time we generate some of the iodine, it gets used up. So that's why the clock reaction is called clock reaction. It gives us time to hit the stopwatch. Reactions are up. This would be so fast. As soon as that iodine forms, the starch would turn black. So in order to buy us some time, we add the S2O3, and that uses up the starch, and then that gives us time to watch it and click the stopwatch. So when that color change happens, we know the iodine has formed, and as soon as the iodine forms, the starch is going to change colors.
We do the first step, right? The first reaction, and then we add the thiosulfate.
We're going to start with 2 different containers, and one is going to have all of our stuff to do both reactions. So on this, in this one, yeah. Oh, so we put them all together. So we have the thiosulfate, and that is a known concentration. So that's going to help us. That's going to give us a concentration to work with, and then the stopwatch gives us the time to work with. So that's our concentration measurement, and then our time is the data we're taking. There's the iodide, and nitrate is just to fill it up, to keep the volume constant and the ionic strength constant. So we have the iodine, we have our clock mixture, and we have the starch. And then we want to keep the volumes constant, and we want to keep the ionic strength constant, so we're using salt solutions instead of pure water. Those things are going to go in the well plate, and then we're going to add the persulfate when the reaction starts. So we'll have 2 things we put together, in this case little well plates that just barely fit the stir bar. It's kind of cool. So we'll add the iodide, and then we're going to add the thiosulfate, and that's when we start the stopwatch. And we'll wait until this is all going to form. The iodine's going to form, but immediately it's going to get used up by that thiosulfate that we added. Right, so we added this to use up the iodine. As soon as this is gone, then we'll see the color change, and we click our stopwatch. So then we can calculate, we're going to calculate the rate. We're going to be calculating it with this concentration of S2O3. And we have to relate these back through the equations. So for this overall equation, for the equation of interest that we're looking for this guy, this is what we want to determine. We're going to determine the rate law for that equation, equation 1. So that hopefully makes sense that that would be measured by this value, right? The formation of iodine in time. So we know how much iodine got used up at the time that the color change took place. And is that related by a factor of 2? That might be a factor of 2, but I'm not seeing it here. Okay. Does that help, or do you have more questions? I have one more thing I can write here. I wanted to add that we know the concentration of iodine that got used up because it relates to the thiosulfate that we added. And what is that relationship? Right, we added a concentration of S2O3 equals 0.0012 molar. Right, I'm using that chemical equation. We know how much thiosulfate we added, and then there's maybe a dilution issue there. 0.012 molar times 2 milliliters over a total volume of 20 mils. Are these really 20 mils? Oh no, this is older. So it's a 2 milliliters. It's not 20 mils anymore. It's 2 mils. So our total volume is 2 milliliters each time. So our initial concentration at the moment that the reaction starts of thiosulfate, that's going to be the original molarity, and we took 0.2 milliliters of it, and then we'll have to divide by that total volume, which is 2 milliliters. Does that make sense? So that would be our initial concentration of S2O3. So this is technically, this one's not quite right. That's what we dispense, but we have to look at the diluted values here as our initial. Then we're going to relate that back to iodine. So in the time that is, let me just calculate that so I can say it. 0.012 times 0.2 mils over a total volume of 2. So that is 1.2 times 10 to the 3. Just divides it by 10. 10x dilution. So if we have 0.0012 molar thiosulfate to begin with, then we know the amount of iodine that got used up in that time. Yeah. Iodine gets used up half as fast, so that's going to be 0.006 molar. 0.0006 molar iodine is formed, right? So if we go back to that first equation, what gets used up in this equation is what is formed in this equation. And we know how much gets formed because as soon as it sticks around and it gives us a color change, we stop the stopwatch. So that certain amount, that iodine, the 0.0006 molar iodine is formed in equation 1 and used up in equation 2 by the time the stopwatch clicks.
So we would have been adding all of these species into the well plate except for the
persulfate, the S2O8.
Yes, and then adding that.
Yeah.
Okay, I see. It's kind of strange to picture all this.
Yeah.
So we put these things in on one side and this in at the time that we start.
And then like the other two molecules, they just like to keep everything constant, right? So we can ignore it. Okay.
To keep the ionic strength constant so that there's the same number of particles in between. You don't have one that's full of nitrates and the other one's just pure water. Those other things are just to maintain the control, to
Okay.
maintain the same conditions.
And throughout the experiment, the amount of thiosulfate is just constant the whole time, right?
Yeah, I believe so. And we can look at that table to make sure. Yeah, that's constant each time. So what we're changing is the iodide concentration and the per sulfate concentration.